Hello and welcome to ICSE Computer Applications for Class 10 Programming in Java. We have already done the revision of all the work done in Class 9. I hope those videos were clear to you. Today we will be starting with methods in Java. Although you have done methods in Java earlier in Class 9 also, but I will redo the stuff. That means we will be doing from scratch again so that everybody is on the same page. Now, what are methods? All these things probably you already know. A method is a name given to a block of code which is used to perform one complete task or subtask. So a block of code, you know what a block of code is. A few statements written together inside braces, that is called as a block of code. Used to perform one complete task or subtask. Now what do we mean by a complete task or a complete subtask? Now let's take an example. For example, there is a bakery. In a bakery, the complete task is actually purchasing the stuff, purchasing flour and sugar and whatever material that you need for baking, then preparing the dough and baking the cakes or the bread or whatever, and then selling it. This is one complete task. Now if I need to break this complete task into subtasks, how would I do it? The subtasks could be cleaning the shop, purchasing the material, creating the dough and baking the stuff, and then selling the stuff. So these all are different subtasks. So when a kind of a system is not very complex, then we can perform everything in one method. We already know about the main method and we have been doing that. So that means in the main method we are actually performing the entire task in that. But when the situation becomes complex, for example, when people were writing Microsoft Word, do you think they did everything in as one big task, or did they create subtasks out of it? So they created subtasks out of it. That means one task was editing the stuff, one task was saving the file or save as or whatever, then one task was checking for spelling mistakes, one task was for grammatical checking for grammatical errors and stuff. So these are all some small tasks or subtasks that is actually part of the Microsoft Word, that is the whole task. So when a system becomes complex, it is better to break it down into subtasks, and each subtask should be performed inside a method. A method is a block of code which only runs when it is called. Now please remember, it is a block of code, yes, but it will not run automatically. We will see the one method that automatically runs, and that is the main method. But a method, that is normally the method created by us, they only run when it is called. Okay, so when we want to execute it, it executes, otherwise it simply remains inside the class. You can pass data known as parameters or arguments into a method. So that means if I want to pass on values to a function, to a method, then I can pass it using something called as parameters, which are also called as arguments. Now please remember, parameters or arguments are the same, methods or functions are the same. Methods are used to perform certain actions, yes, and why do we use methods is when we need to reuse the code. That means I have a small code which is written to find out the factorial of a number. So whenever I need to find the factorial of a number, I will simply use the factorial method. So that means I may be needing to use factorial to find the factorial of a number of times in my program, but will I write the code everywhere? No, I will not write the code everywhere. I will write the code only once, and then I will use it as many times as I want from the method. Now, main method is the only method in Java that is automatically executed. You don't need to execute it by yourself, it is automatically executed. Although in BlueJ we do execute it by ourselves, but when normally applications are created and they are executed, they automatically run the main function inside a class. Now the standard header of the main function is as follows. If you can see, the standard header is public static void main in brackets string args and square brackets, or it could be written as public static void main in brackets string brackets and args. Okay, so that means what is the difference between the two is that the square brackets were written after args in the first one and it is written after string in the second one. So both of them are exactly the same. You can write them in the same way. In BlueJ we can write the header of the main function as public static void main function. So we may remove the string args also from in between, it doesn't matter to us. But when we are actually working in a production environment, we will use the first two headers. Okay, let us see the structure of a method. Now in the structure of the method there are basically four things. One is basically the return type, the method name, the arguments and the method body. Now let me identify the four parts to you. The first part is here. This is the return type. Return type is void. I will explain about this return type a little later. The name of the function or the method, that is the method name, is add. These are the arguments being passed to it. This is the third part. And the method body, that is the method body is within the braces. So that means this is the method body. Okay. So number 1, number 2, number 3 and number 4. These are the four parts of the method. Now please remember, method or functions are interchangeable names. They can be used interchangeably. Arguments or parameters, these are also interchangeable. Basically terminology is different in different books, but the things are the same. So methods or functions are the same, arguments or parameters are the same. Okay, let us see the rules of a function. The rules of the function is that the arguments are optional. That means you may or may not use them. Okay, so that means you may or may not use arguments at all. If there are more than one arguments in a method header, each argument should precede with a data type. So that means int m, int g, float g, char c. So that means c, g and m, three variables, all of them are starting with a data type. Okay, now it doesn't matter whether the data type of all of them is the same. For example, if I want to create three arguments called m, g and c, all of them of type int, I will write it as int m, int g, int c. Now it doesn't matter whether all of them have the same data type. I cannot write it as int m, g, c. I cannot write it this way. Now please remember, this is how you will write when they are arguments, and this is how you will write inside the method. Okay, so inside the method you don't need to write int m, int g, int c. You will have to write only int only once and then give the list of the variables. But as arguments you will write them as int m, int g, int c. I hope that is clear to you. The method body may be empty. Yes. So even if you create a function which has an opening brace and closing brace and nothing inside the braces, you just have the return type and the name of the function and the arguments, then you may or may not write anything in the braces. Even if you don't write, it is okay. So what is this function? What will this function do when it is called? It will do nothing. But can it be called? Yes, it can be called. Okay, so this rule should be very, very clear to you. Let us now dive into programming. That means we'll start with BlueJ now and start with programming. Okay, we have created a function here called main function, and when it is executed, it basically displays hello on the screen. So let me display the hello on the screen. System.out.println bracket hello. Okay, so when it is executed, it displays hello on the screen. I don't think there should be any problem with this program. Okay, so let me compile it. Everything is running fine, no problem. Now let's say I want to create a function which is actually going to display hello on the screen. So that means the hello on the screen, we will remove it from here and create a function void. For example, we call it as say hello function and open and close braces. Can you see that the structure of the main function and the structure of the say hello function are exactly the same? I just need to put public here. Okay, I need to put static here. Alright, the structures of both of them are exactly the same. The only difference is that the name of the previous function was main and the name of the next function is say hello. Okay, what I need to do is put the same statement here now. Okay, can you see that both these functions, that is the main function and say hello function, are basically comprised of 4 parts. It is basically comprised of void, main function, in brackets there is nothing, so no arguments, and the braces to identify the body. Okay, public and static are not actually part of the definition of the function. They mean something else. So meaning of that public and static will be done when we come to public and static, not right now. Right now we are basically concerned with the 4 parts of the function only, but we will be writing public and static in the header of each of the functions. Okay, so you should remember that. Okay, now I've created a function called say hello function. I've created a function called main function, and if I run this program now and if I execute the main function, what is it going to do? It is going to do nothing. Why? Because say hello function has not been called from anywhere. Now please remember, from outside the class, I will always run the main function. I will not try to run say hello or the other functions. I can, but I will not. Okay, so let's be very clear about it, that whenever you want to execute programs from within a class, you will execute a main function only, and you will not execute the other functions. You may create them but don't execute them. So if I run this program, if I close it now and if I go to compile and run the main function, I will see that in the terminal window that it has actually not displayed anything, so it's showing blank here. Okay, let's see the program again. What I'll do now is I will execute the say hello function. How do we execute the say hello function? We give the name of the function. The name of the function is say hello. We put open and closing brackets after this and end it with a semicolon. So what is fixed is what you see here. You will always be doing this to execute a function. That means you will write the name of the function, you will put opening and closing of brackets, then you will put a semicolon at the end. So this is actually going to be called as call. Okay, so this is the call. What you see below is actually called as the definition. Okay, how many definitions do you see here? I see 2 definitions. This is the definition of the main function. Okay, and this is the second one, is the definition of the say hello function. Okay, so I hope it is very, very clear to you. So how many calls do you see? You see just one call. And how many definitions you see? You see two definitions. This part, that is this part, is the definition of the main function. This part is the definition of the say hello function. This line is the call to the say hello function. Okay, so this line will actually execute the say hello function. Let us now compile it and run it. Okay, so let me run the main function now. Let me see the terminal window, and the terminal window shows hello. Let's see the program again. How many calls did I make? 1. Let me have 2 more calls. Okay, what will happen now when I run the program? When I run the program main function, it will execute say hello thrice. That means say hello once, it will be displayed. It will display hello. Second time it will display hello. Third time it will display hello. Let us see how does it work. Let me execute main function. Let's see the output. Now is hello, hello, hello. So it has displayed hello 3 times. Alright. How does it actually work? Let me show you the working of just one of the say hello functions. This is the call to the function. Okay. When we run this program, we were actually executing the main function. So when you execute the main function, it executes everything inside the main function. So the first thing that you see here is say hello. Okay. Let's say I have also written a statement called start, and also have written a statement which displays end. So basically main function has 3 statements. 2 are basically displaying something, and 1 is actually calling a function, calling another function. So what will happen now? When you run the main function, when you execute the main function, the first statement will be executed is system.out.println start. It will display start on the screen. So terminal window will get the start message. Okay. Then this is actually a call to another method. So when it is a call to another method, it will not do anything here. It will actually pass the control to this method which is being called. So that means, this means what is going to happen now is that the call from here will transfer the control from there to the say hello function here. Okay. Now the say hello function will be executed. See, naturally, when say hello function is executed or method is executed, it will automatically perform whatever is inside the say hello method. So what is inside the say hello method? There is only one statement. So it will display hello on the screen, and this is the closing brace of the method. So when the closing brace of the method appears, the control goes back to the same statement from where it was called. Okay, so you can see when the main function was executed, the first statement executed was system.out.println start, then say hello. From here the control went to say hello function, displayed hello, the control came back to the same statement. Now there is nothing else in this statement to execute. It goes to the next line and displays end on the screen. So in which series have things happened? Main function starts, start is displayed, say hello is executed, say hello is executed, so it displays hello on the screen, returns to the same statement as it from where it went off to, then goes to the next line and displays end on the screen. Okay, let me just show you the running of this program. When I run main function and see what is the output is start, hello and end. This start has been displayed by the main function, this hello has been displayed by the say hello function, and this end is displayed by the main function again when the control returns to the main function. Okay, I hope this stuff is very clear to you. Okay, I have called this say hello function only once, so if I copy this and paste it somewhere else, it will perform that call that many number of times. For example, if I put it, for example, into a loop which is x is equal to 0, x is less than or equal to say 5, x plus plus, and I put it inside braces and put this here, how are things going to happen now? Start is going to display once, end is going to display once. They are not in the loop. What is in the loop is say hello function. So it is starting from 1 to 5. That means it will run 5 times. Say hello function will be executed 5 times. So how are things going to happen? Start is displayed. This loop happens 5 times. So in the first one, call is made, say hello is displayed, returns, then goes back into the loop. Second loop, and it displays, it runs a say hello function again, goes to say hello function, displays again, comes back, and so on and so forth. So what do you think this is going to display now? This is going to display hello 5 times. Okay, so let's run this program. You will see that it displays hello 5 times, and 5 times the function has been called. This is what is meant by creating writing a function once and calling it many times. Okay, the function that we made now was only displaying hello on the screen. Suppose I want to make a function which I want to pass something, and whatever I pass it, it displays that. Okay, let us see now. I have created this function now. I have put in an argument called s. That means whenever I need to call it, say something, maybe say something hi. Okay, so say something hi. Now say something function will be called. Hi will be passed as an argument to s. Okay, so this is now the second kind of a function which is now to which we are passing something. So we are passing hi to s, and this displays s as hi. Okay, so if I say something and say Chandigarh. Okay, so in the first call hi was displayed to s, and when this displays s it will display hi, and in the second call Chandigarh is passed to s, and when it displays s it will display Chandigarh. Okay, so let us see now how things happen. Let me run this, and you will find that it displays start, hi, Chandigarh, and end. Hi was displayed when say something was called with hi, and Chandigarh was displayed when say something was called with Chandigarh as an argument. Okay, I hope this is clear to you. Okay, next, there's another function that I have created. The name of the function is add, and when it is called, this function is going to create 3 variables a, b, and c. A and b are going to have values of 10 and 20. C is not going to have a value at that point. Then c gets the value of a plus b, that is c will become 30, and ultimately this function displays the sum of a and b is c, that is the sum of 10 and 20 is 30. So let's run this program and run this main function. It displays the sum of 10 and 20 is 30. Okay, fine, good. Okay, next, so this is the call. As you can see, the call, the function name now is add. So when it is add, you will write add as in the call, then you will put open and closing brackets. I have not passed anything here, so there is nothing passed here, and ending with a semicolon. Please remember, the header of the function definition does not end with a semicolon, so there is no semicolon here. The semicolon will always be with the call. Now you should remember this now. Now this is the first kind of a function that we have created. We had written say hello function, that is something similar to it. What happens when I call add function once or twice or 30 times or 50 times or 100 times? Don't you think every time it is going to display the sum of 10 and 20 is 30, the sum of 10 and 20 is 30, so it is going to do the same thing. Do I always need to add only two numbers, 10 and 20? Don't you think I need other numbers also? Right? So what do? I say while calling, I will pass it the numbers. So that means I will not just execute it, I will execute it with the numbers. So if I am passing numbers to it, so what I'll do is I'll create the two variables as arguments here. So that means 3 as the first argument will be passed to A as the first argument. And naturally A and B will be removed from inside the function and only C is required because A and B have already been created here. Now this is the second kind of the function where we are actually passing values to it. Now please remember 3 and 6 are also called arguments, A and B are also called arguments. But arguments from here are called as, they are called as actual arguments. Okay, they are called as actual arguments. And the arguments here, that is A and B, are called as formal arguments. So actual arguments are the ones which are actually sending values to the function. Okay, and formal arguments are the ones which are actually receiving values from the call. Okay, are we clear? Okay, now what is going to happen now? How many actual arguments? 2. Naturally, how many formal arguments? 2. 3 and 6 are being passed to A and B respectively. That is 3 is passed to A and 6 is passed to B. So A and B are 3 and 6. So C will get the result of A and B, that is 3 plus 6 is 9. So what it will display? It will display the sum of 3 and 6 is 9. Let me try calling it again. Say add with 23 and 29. Okay, then I'll call add with 41 and say 62. Okay, let me call these now. Let me execute this. Let me compile it and execute it. You will find that the 3 calls have displayed the sum of 3 and 6 is 9. This is the first one that we made. The second call actually passed on 23 and 29. So it says 23 and 29 is 52. And the third one says 41 and 62 is 103. Okay. So the calls have resulted in different kinds of data to be displayed by the functions. Now the responsibility of giving the data to the function now lies with the function which is actually calling it. So main function will actually pass the data to it. There is no data inside add function. Add function is actually receiving data from somewhere. So when we have arguments, we are actually receiving data from somewhere. Okay. I hope this part is clear to you. Now there is the third kind of a function which is basically not only doing some work, it is also being passed some values, but it is also returning some values. Okay, let's consider what do we mean by returning a value. What is the result going to be when 3 and 6 are added? It is basically 9. Alright, so if I display C here, what is it going to display? It is going to display 9, and when the call happens through 23 and 29, it is going to display 52, and when 41 and 62 is they are passed, and then this displays 103. Now the 3 values, that is the 9 value and the 52 value and the 103 value, so these are the 3 values. They are actually consumed inside the add function only. They do not actually go back to the main function. The main function doesn't know anything about what is the result of those 2 numbers being added. Okay, this is something like you give your younger brother or sister some money to buy samosas, and your brother or sister goes to the market, buys 2 samosas, consumes the samosas and comes back to you. Do you get the samosas? No, you don't get the samosas. No, I want the samosas back from from the function. Okay, so what do? C is actually the result of this entire processing, isn't it? So instead of writing print C, instead of displaying C here, what we will do is we will say return C. That means please return this value back to the function where it came from. Okay, so what is it returning? Instead of displaying C, it says return C. That means this value is going to go back to the main function. Alright, we need to make a small change here now. C is being returned by this function, and if the return is C, then C is of type int. Naturally, we will need to change the return type here to int. Okay, so you have understood now. In the previous functions, we were not returning anything, so naturally we were writing void over there because I am not returning anything at all. Now I am returning an int, so I will write public static int add function. If suppose C had been a float, I would have written public static float add function. I hope that is clear to you. Now one more thing to consider here now. The value is being returned to the function. So when the samosas are returning to you of course, then what do? You keep a plate ready for the samosas. Alright, so when your younger brother or sister, they return with the 2 samosas, you put those samosas into that bowl or plate or whatever container you have prepared it for. So we need to prepare a container. So we will prepare a container. M is the container now, okay, because I need an int value to be stored, so I will use M as the container. So how am I going to store it here? I'm going to store it like this. I'll say M is equal to add 3, 6. So what will happen now? Okay, 3 and 6 pass to A and B are 3 and 6, C becomes 9. This returns a value of 9. That means this function call actually results in a value of 9, and then 9 is actually assigned to M. This is an assignment statement, it is assigned to M. Are we clear? If I now display system.out.println M, what do you think it is going to display? It is going to display 9 over here. Okay, so how has the data gone and how did it come back? 3 and 6 is passed to A and B is 3 and 6, C is 9, 9 is returned, and the returned value is passed to M. Okay, so what do you think M will display here? M is going to display 9. If I use a statement like this and a statement like this, and I put the values as M is equal to, then put the value as M is equal to, so what is going to happen now? In the first one, it is going to display M as 9, then 52, and then 103. Okay, let's run this program and see how things happen. Let's run this program. See, it displays start, and then 9, and then 52, and then 103. So these are the 3 M's that have been displayed. Please remember, M is actually changing every time you make a call. Okay, I hope this is very, very clear to you. This is the function call, this is the function definition, these are formal arguments, actual arguments, these are formal arguments, this is the return value, and this is where the returned value is stored. Okay, understand one more thing. If I write it this way, what is going to happen? First of all, there is no error anywhere, so that means if I compile it, it will compile fine. Okay, but what is going to happen now? When I call this add 23, 29, it is going to call, the numbers are going to be added, the value 52 is going to be returned, but the returned value goes nowhere. So that means it simply vanishes. So it doesn't go anywhere. So if it doesn't go anywhere, so M does not change. What do you think this is going to display? You can pause the video and then check your program, check your result. After unpausing, let me run this program and show you what the result is going to be. So it is going to be 9 and 9 and 103. So why is it showing 9 and 9? Why 9 and 9? Because when the first call was made, 9 was assigned to M becomes 9. In the second one, I executed the function, but I did not store it anywhere. So M still remains 9. Whatever was displayed here is displayed here. In the third call, I actually stored it again. So it is going to work fine. Alright. Now I've changed the program again, and this program actually contains two calls on the same line with the plus sign in between. What do you think is going to happen first? This call is going to be executed first. Whatever result comes here will be added to when the second call is made second. Whatever result comes here, both these numbers, the previous call's result and the new call's result, they are going to be added, and the result is going to be stored in M. Now what is going to be the result of add 3, 9? It will be 9. 3, 6 will be 9. Add 4, 2 will be 6. So 9 plus 6 is 15. M is going to display as 15. So if I go back and display, when I run the main function, it displays 15 over here. Okay. So you can see that in this particular statement, how many jobs, how many tasks are being performed? One call, second call, addition, and assignment. So there are 4 things that are going to happen. And in that same order that I have spoken, the first call 3, 6, the second call 4, 2, then the addition happens, then the assignment happens. Okay. I hope we are very clear about this. Okay, now I have created a function called fact, which is basically calculating the factorial of a number which is passed to it. You have been basically creating these functions, these programs earlier also. You know how to find the factorial of a number. You simply take a loop which starts from 1, goes up to n, which is the number itself, and then keep on multiplying x into and keep on storing it into f. Okay, so the logic is f has to start with the 1. It is an accumulator, but it is using a product, so naturally it will start with the 1. Next is it returns f. F is actually the result of the entire process. So f is returned, and when f is returned, that f is going to be returned into m. This will display the factorial of 3 is whatever. So factorial of 3 is 1 into 2 into 3, which is 6. So this program should actually display the factorial of 3 is 6. Okay, fine. Now 3 is a fixed number. Okay, suppose I want to take input from the user and I want to display the factorial of that number. How would I do it? I'll have to take input. So that means I will take, say, G as an input, and G is equal to, I will take input from the user. Okay, I have changed this program now, and the program now is taking input from the user. So I've created a variable called G, buffer reader object, or display on the screen, and it takes input from the user. So this is the part which is taking input from the user in the form of an integer, and it is being stored in G. G is now being passed to the fact function. Okay, so that means G, if G is for example 10, what do you think will be passed to fact function? 10 will be passed. So G will be 10 and 10 will be passed to n. N will also become 10. So this loop will go up to 10. 10 times it is going to add the numbers, and whatever it returns, it is returned to m. And here we actually need to change this plus G plus is so and so. Okay, let's run this program and see how things happen. Please enter a number. Suppose I write 5 and enter. It says the factorial of 5 is 120. Again I call it, and if I say 7, it says the factorial of 7 is 5040. What do you think if it will do if I put a -3 here? It is going to display a 1. Yes, I think in mathematics the factorial of all negative numbers are 1. So coincidentally we didn't do anything about it. This is actually doing by itself. Okay, all right. Let's say I want to display the factorials of all the numbers from 1 to g. Okay, so what do I need? I need a for loop. Let me start a for loop. Int x is equal to 1, x is less than or equal to g x plus plus, and let me put everything into brackets now. Alright, so what will this do now? Let me compile this and execute it. It displays, please enter a number. Say I say 7, so it displays, okay, 7. Okay, why is it showing 7? Because I did not change that g in the function call. Let me change the function call. The function call is always getting a g. Let me make it an x, and what is going to happen now is when I call it with the 7, it displays, sorry, I should have changed in the system.out.println also. So 1, 2, 6 and so on and so forth. Okay, let me change that. So g also should have changed to an x, and then let's see, run the program. Let me have another number, say 9. So these are the numbers. Factorial of 1 is this, 2 is this, 3 is this, 4 is this, 5 is this, and so on and so forth. Okay, I hope the functions, working of the functions are clear to you. We know how to call functions, we know how to define functions, we know how to pass arguments, we know how to return values from arguments. We know the structure of a function and the rules regarding the functions. I hope things are clear, and we'll meet in the next session now. Thank you for listening in.